Good day, grade 11 learners of South Africa. We are here today. We're going to be doing circulation or transport, part 2. We've done part 1. We've done all the structures of the heart. We've done diastole and systole and relaxing and stroke volume and cardiac cycles. Now we're going to be looking at the actual structures. All right, so we've got transport system part 2, and we're going to be looking at our blood vessels. Now, we have a closed blood system, and if you don't know that by now, heaven help us. Okay, closed means it flows inside veins or arteries or a structure of sort. The blood doesn't just bathe the organs like with an open circulatory system, for example, in insects or all your different arthropods. All right, as blood flows in tubes called blood vessels. And that should be your definition. Arteries carry blood, remember A for artery, away from the heart. So your pulmonary artery will be carrying blood to the lungs, away from the heart. It will be deoxygenated, all right? And your aorta carries blood to all the parts of the body for systemic circulation. Please remember, people, we have double circulation. All right, veins carry the blood back to the heart. Capillaries are located between the arteries and the veins. So think of your capillaries as the little streets in between where your houses are, where you live. And think of your aorta and your superior and inferior venae cava vessels as the highways. All right, the highway between Joburg and Pretoria, for example, or between Pietermaritzburg and Durban. Okay, blood vessels. Now, you must understand the structure versus function. So, structure versus function. Why does it look the way it does? Because it does job A or job B or job C. Now, if we look at an artery, okay, it has a rather small lumen. Okay, the lumen is that opening in the middle. Okay, it has an inner layer of endothelium, which is your inside layer of cells. It has a muscle layer, so it's got quite a thick muscle layer. Oh, quite a thick muscle layer. And then it has a fibrous outer layer. And if we look here, the diameter is about 5 millimeters. For the vein, it also has, okay, first, sorry, the artery's got 3 layers, whereas the vein has an outer 2 layers, which are thinner. So it also has the 3 layers. It is also 5 mils. So they are both 5 mils in diameter. But look at this. The lumen is large. It's got a large lumen, that middle cavity is large, okay? It's got the endolayer of endothelium, the same as the artery. The muscle here is thinner in comparison to the artery, and it has the fibrous outer layer. Now, what have we got here? In the artery, we've got more muscle and a smaller cavity. All right, smaller lumen. That muscle layer is able to expand or contract. So to dilate or to constrict. Okay, and I just want to show you here. By now, you need to know dilate, constrict. Constrict means to go small. Dilate means to increase the lumen size. So dilate, get bigger, and I'm putting that in inverted commas, and constrict, to get smaller. Okay, and it's the muscles that will cause it to dilate or constrict. Okay, so looking here, we've got this thick muscle layer and a smaller lumen. Here we have a large lumen and thinner muscle layer. Capillary, one layer, one single layer of endothelium. So it only has one layer of cells. And that is why we are going to have easy diffusion. Okay, there'll be easy diffusion of nutrients, of gases, waste products. All of that is going to be able to move through the capillaries very, very easily. Another thing that you need to understand is you have the artery. The artery splits up into arterioles. Each arteriole will split up into a capillary network. Okay, so it's a network of capillaries, lots and lots of little capillaries, all right? Now, the blood coming back, your capillary network is going to join up to form venules. Those are little veins. And your little veins all join up to form a vein. And in the middle here, we have the heart. Okay, so the blood from the veins is going to flow into the heart. That blood's going to go to the lungs. The blood from the lungs are going to put oxygen in, that's going to go back into the heart, and that's going to go bloops to all the parts of the body. And that, people, is systemic circulation and pulmonary circulation. Now, if you look at the blood vessels, you must know the difference between arteries, capillaries, and veins. If I was setting your exam paper, I would ask you to either compare arteries and veins, or arteries, veins, and capillaries, or arteries and capillaries, and I would probably ask you for 3 differences, and +1 for drawing the table will give you 7 marks. Okay, so arteries always take blood away from the heart. It has a thick middle layer, which is involuntary muscle, and that will increase or decrease the diameter. And what does that do? That's going to increase or decrease pressure. Okay, remember, if I have a tap and that tap is running and I put my finger there and I close the hole, I can spray the water. Why? I'm increasing the pressure. Right? Pressure. The minute that hole gets smaller, it has a narrower inner layer, so the endothelium, which reduces the friction. It's situated deeper in the tissue, so it can keep the temperature. Your arteries don't flow outside here. You can't see an artery. You can see your veins. Okay, you can't see your arteries. Your arteries are in here. If you want to feel for your brachial artery and you want to do your blood, have a look for your pulse, you've got to actually literally get your fingers right in there, all right? The veins are surface. The arteries are inside. Your carotid arteries right in here, whereas your veins, jugular veins, are right here. You can see them. They're easy to see, all right? No valves except at the base of the aorta. Remember, that valve at the base of the aorta is a semilunar valve. And the blood is always under very high pressure because the muscle layer, which is involuntary muscle, can change its shape. And it's the hypothalamus and the medulla oblongata that will cause that to happen. All right, now, if we compare to the veins, so let's leave capillaries for now. The veins, they always take blood back to the heart. The thick middle layer of involuntary muscle is going to reduce the pressure, okay, because it's bigger. The larger diameter in the inner cavity is filled with endothelium, which reduces friction, all right, and it's larger in diameter, where here it is narrower in diameter. Thick middle layer, thin middle layer, all right, situated inside your arteries, whereas your veins are near the surface. So when they take your blood and you go to a pathologist and they're going to take your blood, or a sister, here, this thing that you can see, and let me undo this quickly. Okay, and you just hold it there and pump your hand. So just hold it a little bit and pump your hand. You'll see that there are structures, blood vessels that stick up. Those are nice, dark blue veins, and they are carrying deoxygenated blood. That deoxygenated blood still has nutrients in it, but it has little oxygen and more carbon dioxide. Okay, so larger diameter, situated deeper in the surface, whereas here it's near the surface, we can see it. There are semilunar valves. Now people, think about it. You've got the blood in the veins, all right? And this blood goes, it's got to come from your toes. So arteries, the blood's going downhill. It only has to go uphill from here. Your veins has to, okay, it's only got downhill from here, but my gosh, it's got to come all the way from your toes, all the way from your tippy end of your big toe, all the way up into this inferior venae cava into the heart. So it's a long way. And every time the heart has diastole, so when we have atrial and atrioventricular diastole, the whole heart relaxes for 0.4 seconds of each cardiac cycle, there's nothing forcing that blood up. So we've got to stop the blood from flowing backwards. Otherwise, we'll sit with all our blood in our feet. Okay, so you can't have that. So what happens? We have valves, semilunar valves. The same valves that we have in the pulmonary artery and the aorta, we have in all the veins in the body, little semilunar valves. So they go face this way, and as the blood goes up, cool. And as soon as the pressure decreases and the blood starts to flow backwards, the valve closes. And up and down. So that's how the flow is from the bottom of our body, up the vessel, through the semilunar valve. As soon as the pressure decreases, the semilunar valve closes. All right, so semilunar valves, whereas in the arteries there are no semilunar valves. All right, or at least there's only one at the base of the aorta, but nothing in the actual veins. And then here the blood, the pressure is always low, whereas in the arteries it's high. Now remember, your capillaries are one layer. So one single layer of cells. So it's blood supply to the at tissue level. We have one layer of endothelium. It's only endotheliums present and not a whole bunch of other layers. It's situated at tissue level only. You don't find capillaries anywhere else. There are no valves. They're so small that they really don't need valves, okay? And the blood is under very high pressure. Why? Because it's coming from the artery. The artery is going from an artery to arterioles, lots of arterioles, to capillary network. There's pressure. It's coming from something big to something small. So there's always pressure in the capillary networks, and that is because of arterial pressure. All right, people, learn this. Make sure, pick the 3 easiest ones and learn those 3 for all of them. Now, with blood is fluid connective tissue. Now, you learned this in grade 10. All adult humans have about 5.5 liters of blood flowing through their blood vessels. Okay, now, if you are a 6'6" basketball player who is huge, or you are Muhammad Ali and the biggest boxer known to man, you are not only going to have 5.5 liters of blood. If you are a little person who is 5'4" and all petite and little and tiny, you are not going to have 5.5 liters of blood. So remember, we say about. So it is on average 5.5 liters of blood flowing through their blood vessels. Blood consists of, you've got the plasma, which is the watery part, and the hemocrit. Okay, and the hemocrit are all the different cells that we have in the blood. Now, what does blood do? It transports substances to and from cells. The optimum pH in humans is 7.4. Okay, now remember, on a pH scale of 0 to 14, where 0 to just before 7 is classed as slightly acidic, and 7 to 14 is slightly alkali to very alkaline. You've got 7.4 means our blood is just ever so slightly alkaline. Okay? Now, if we look at what blood is made up of, it's made up of the plasma and the hemocrit. And the hemocrit is made up of the red blood cells, white blood cells, and platelets. Now, your red blood cells carry oxygen. Why? Because your red blood cells have something called hemoglobin. And the heme of the hemoglobin means iron. So the hemoglobin is the oxygen taxi, all right? The white blood cells, they're our soldiers. They're our antibodies. They're the guys that actually go around and clean the blood, picking up germs and anything that doesn't belong there. And then you've got the platelets, and every time there's a little bit of a damage here and a little bit of a mess up, they're our maintenance crew. So think of your blood platelets as the maintenance crew. They've got their toolboxes, they've got a piece of whatever they need, and here's a hole, and they plaster that hole up. And they go along, here's another hole in the blood vessel, and they patch it up. That's what our blood platelets do. Okay, so you've got your hemocrit, has red blood cells. They are our oxygen taxis. Our white blood cells, they're our soldiers. And our platelets, they're our maintenance crew. They fix any holes that we have in our blood vessels. And then we have the plasma, which is water and a whole bunch of dissolved things. So here is blood. That's what a micrograph looks like of blood. And you'll see, for example, remember your red blood cells never ever have a nucleus. So these would be your red bloods. Oh, hang on, let's get another color here. And I don't know what color is actually going to show up on here. So let's try the pink. Those are your red blood cells or your red blood corpuscles. The ones that look like this, that would be a white blood corpuscle, and that would also be a white blood corpuscle, and there's another white blood corpuscle. Okay, and your platelets would be the mush and the stuff that you see in between. So here's another slide. This that looks like a donut is your red blood cell or your red blood corpuscle. Those would be your platelets or your thrombocytes, and your white blood corpuscles or erythrocytes. Sorry, leukocytes. Leukocytes, erythrocytes, and then your platelets. And your platelets, your maintenance guys. Okay, so blood groups and transfusions. Now this is quite important, people, and it can actually help you one day when you get to a hospital and there's an issue with blood and you need a transfusion, or a family member needs a transfusion. So make sure that you understand this very carefully. When a person loses a lot of blood for an operation or there's an accident, that blood must be replaced. Remember, we're looking at on average, we're looking at about 5.5 liters of blood. Okay, now if you and I promise you now, if you cut your finger or you cut your head, you're not losing liters of blood. You're probably losing not even enough to fill a tenth of a cup, and it's a lot of blood. Right, so you have to lose a lot of blood to actually make an impact. So a blood transfusion is when blood is taken from another source, so it's any other source, and is put into a recipient. Okay, and they will always use a vein. All right, why? Because they've got to go digging for an artery. So logic tells you that, hello, there's a lovely vein sitting right here or right there. Let's rather use that than go digging in here to try and find an artery. Okay, so that's why they will always do it via a vein. In many cases, blood is donated and stored in blood banks. Now, especially before the December holidays, you'll find the blood banks or the blood bank of South Africa will do an absolute outcry to people and say, please, 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 we need blood. Why? Because during holiday periods like the Easter holidays, the December holidays, people drive like idiots on the roads. And when they drive like idiots, you end up with accidents. Cars are overloaded, people don't check their cars, etc., and accidents, and people get tired driving, so accidents happen. Or if there's an operation, now people lose blood, they bleed out. So what happens is you've got to put that blood back. Okay, and where do you get it from? You get it from the blood banks. And where do the blood banks get it from? From us. when we're healthy and everything's fine. They have it at shopping centres. They put little screens up and you can go and donate blood, and you donate 1 pint, which is about half a litre of blood, and they give you cool drink and they give you a biscuit or a cup of sweet tea and a biscuit to get your blood sugar up, and then they send you on your merry way. This is donated blood. We don't pay for blood in South Africa. You do. You pay the hospitals and you pay the blood bank for the blood, but you don't get paid for giving blood, which is not, it works differently overseas. But anyway, this donated blood, first of all, has to be tested and it's checked. And it's checked if it isn't infected in any kind and in any way, and also to check what blood type it is. Because you cannot just give this red stuff to anyone. It has to be compatible with the person. Otherwise, their blood is going to react and that blood's going to clot and you end up blocking up all the blood vessels. So when we donate blood, it has to be tested. Now, in the old days, they didn't test all the blood. And that meant that HIV infected blood just fell through the cracks. And people would go for a blood transfusion, and you'd go in for a blood transfusion and it'd come out with HIV. And not through anything that you'd done, it was bad blood that you were given. Nowadays, because of the awareness of HIV, every single drop of donated blood is checked. All right, every single drop is checked and confirmed and verified. Okay, in some cases, especially when the blood type is rare, like AB negative or B negative, a family member is able to donate blood directly to the recipient. So what they'll do is they'll have you sitting there, they'll stick a needle in here, and they'll just link it up to the person. All right. If the blood is not compatible with the recipient's blood, the donor blood, so this is when you're having a direct transfusion, will clot, and it will cause death of the recipient. So you can't just go giving people the wrong blood. Okay, they're the bags of blood. So when you go and donate blood, this is what it's gonna, they put it into little bags, and then those bags are tested, and then they put stickers on it. And in some cases, they actually take the red blood cells out and end up with only the platelets or the plasma. And they then use that for different things as well. So blood groups and transfusions. We have the blood type, and it's compatible with which donor blood. Now, I want you to have a look at a trend here. Look here. If it's AA, then it can be you are compatible with either A or O. Okay, so they can give you, if you are AA, they can give you A or AO blood, and the same with AO. Okay, they can give you that blood, and you'll be okay. With the Bs, it's BO. And BO, they can give you BO, clearly. AB, look at this. A person with AB blood can accept blood that is AB, that is A, that is B, and that is O. And then clearly, if it's O, well, O is going to be compatible. Now, just look at this, people. Do you see? You've got O blood fits with all of them. No matter what the blood, if it's AA or BB or AB, O fits with all of them. So we say that O blood is the universal donor. Okay, so if you've got O blood, the people at the blood banks want your blood. I mean, they're like vampires. They want your blood because your blood can be used for any blood group. All right? And look at this. AB is called your universal recipient, because a person with AB blood can get blood that is AB or A or O, B or O. So they can receive any blood, and O can always give to anyone. You've got to remember that. So universal blood donors, okay, or universal donors is blood O because it's compatible with all the other blood groups, and universal recipient is going to be AB because they can receive from any of the groups. Now, we look at a rhesus factor, and everybody says, I know I have battled in past years to teach this to my learners, and it's so simple. So just listen, and if you just listen carefully. On the surface of the red blood cell, okay, because remember it's your red blood cell that carries the oxygen. On the surface of your red blood cell, you have a protein. If the protein, or a protein can be there, if there's a specific protein, then we say you are rhesus positive, because it's a rhesus protein. If there is no rhesus protein, then you are rhesus negative. It's as simple as that. So, when the rhesus antigen is on the surface of the red blood cell and it's present, then you are Rh positive. The Rh is for rhesus. Okay, it's for that word there. When the rhesus antigen is absent, then you are rhesus negative. It's as simple as that. So the rhesus system can cause complications during blood transfusions, pregnancies, and birth. Why? Because if, for example, a woman has a baby and she's carrying a baby, and that baby has a different rhesus factor to what she is, your blood is going to make antibodies against the baby. And that is what the problem is. That's what creates a blue baby, for example, when they're born. Okay, and it just gets worse and worse every time, because your body's going to make more and more antibodies every time you're pregnant. Okay, blood transfusions, you are not going to be able to give somebody rhesus positive blood if it's going to if there's going to be a conflict, because the minute you do that, the blood's going to clot, and then we're going to have a big problem. Okay, people, let's look at our first question, and it says, study the diagrams which show a cross-section. Now, just to recap here, because sometimes learners battle with this too, a cross-section is if I cut through it this way. A longitudinal section is if I cut through it that way. So if we go back to our little goodie of the heart here, what we see there would be a longitudinal section. If I cut through it here and we looked into the top, it would be a cross-section. Or simpler, if you take a carrot and you cut little medallions of carrots, so little round ones, then that's cross-section. If you cut longitudinally through the carrot, then it is longitudinal section. So here's a cross-section through our blood vessels. Now, rule number 1, and I've said this 1,000 times, is whenever you get a diagram, the first thing you do is label. So we've got A and B. A has a large lumen, so look at that large lumen, so we know this is a vein. And this one's got a small one, so it is an artery. How do we know it's not a capillary? Because it has got more than one cell layer. Remember, capillary is one layer of endothelium. All right, then here we've got I'm just looking at we've got connective tissue. Okay, 2 would be your endothelium. Remember, the inner layer would be endothelium. This gray area here, which is number 3, okay, is your smooth muscle. Okay, and number 4 is going to be the lumen. Now, remember, your lumen for your artery is smaller, and you have more smooth muscle. It's a thicker layer of smooth muscle. In your vein, you have less smooth muscle, but you have a very large lumen. So here the lumen is large, and there it is small. Okay. Let's look at our questions. Which vessel, A or B, is the artery? Well, we already know B. Okay, provide 2 reasons for your answer. Well, we've just gone through them, people. First of all, it has a smaller lumen than A, and it has a very thick, smooth muscle layer. Why? Because we can control blood pressure. As those muscles contract, we then make the lumen smaller, which means we put the blood under pressure. And if we want to release that pressure, then the smooth muscle will relax. In other words, it will dilate, and the lumen, or the hole through the middle, called the lumen, is going to expand, and it will slow the flow down. Okay, which blood vessel carries blood at low pressure? Now, low pressure is always going to be blood vessel B. Oh, sorry, blood vessel A, because we said B was the artery. So blood vessel A, which is the vein. I'm just writing vein in here so that you know. All right, provide one reason for your answer to question 1.3. So why do we say that it's a vein that carries blood pressure at low pressure? It's going to be because it wants to large lumen, or you could say that it has a thinner, smooth muscle layer. Okay, that would be a reason for your answer, because it then decreases the pressure. Okay, if we look at question 1.5, it says identify the parts numbered 1 to 4. So we're going to have 1, 2, 3, and 4. Let's see if we can remember them. Or we're just going to look here. You can write it in on your sheet. Okay, 1 is the connective tissue. 2 is going to be the endothelium. 3 is going to be the smooth muscle. And 4 is the lumen. Those are the 4 components of your arteries and your veins. All right, so let's just go through them again. 1 is connective tissue. 2 would be the endothelium. 3, the smooth muscle. And 4 is the lumen. It's that cavity right in the middle. Okay, how do capillaries differ from larger blood vessels? Remember, capillaries are simply one layer of endothelium. Okay, that's all they are. They have one layer of endothelium, or you can say that the cell layer is a single layer of endothelium. Doesn't matter how you put it, as long as you make it very clear, it's only one layer of cells, and that is endothelium. All right, then, in which vessel, A or B, would you expect to find valves? Now, we're going to find valves in veins, and A is the vein, so it would be in A. Why? Because it is a vein. Can you remember why we have blood vessels in the veins? To prevent backflow of the blood. Right, the blood gets pumped, sure, via the aorta, and the pressure goes from the aorta to the arterioles, to the capillaries, and a little bit to the venules, but now it's decreased because it's going wide, and then to the veins. So to prevent that backflow, we're going to have semilunar valves. All right, what is the function of the valves in 1.7? To prevent backflow of blood. Okay, and then we look at question 1.9. Name the blood vessels that carry deoxygenated. Now people, look at what I'm doing. I'm underlining the word they want from me. Deoxygenated blood from the heart to the lungs. So if it's leaving the heart, it's going to be an artery. And if it's going to the lungs, and it's the blood the lungs work with, it'll be the pulmonary artery. All right? That carries oxygenated blood from the heart for systemic circulation. So it's leaving from the heart. It's going to be an artery. What's the main artery for systemic circulation? Is the aorta. Okay? And then carries blood from the digestive system to the liver. It's going to be the hepatic. Because remember, anything to do with the liver is hepatic, but it's from the digestive system. So we've got already had a set of capillaries there. We have our next set in the liver. So it's the hepatic portal vein. Okay. Now we go to the lymph system. The lymphatic system is a system of nodes and vessels that basically help you to clean your body. So it's like an extra cleaning process. So if we look at the fluid in the body, we've got blood, which is made up of the plasma and the cells, which was the hematocrit. Okay, we have the fluid tissue, and we have lymph fluid. The lymph vessel tissue fluid is going to bathe the cells. So you'll have, if this was a group of cells sitting here and you've got your capillaries around it, your blood, so let me just do it like this. This here is tissue fluid. So that should be tissue fluid, and then all around the cells, and then you have your lymph fluid. And your lymph fluid drains any excess tissue fluid and fats away from the cells. So they would sort of be open-ended little structures that would be here, and that would end up being your lymph vessel. So those are the fluids in your body. Blood, which is plasma and your hematocrit, tissue fluid, which bathes the cell, and your lymph fluid, which is going to transport excess fluid and carry fats. Now, if we look at the lymphatic system, I've put this diagram into the X sheets, all right? The most important thing you have to look at here is the fact that we have the heart sitting right in the middle, and the heart pumps blood. The lymph system is also a transport system. Now remember, the lymphatic system is going to carry excess fluid, germs, and fats to the neck area. Okay, so it's going to carry it to the neck area because your lymphatic system joins the rest of circulation at the junction of the subclavian and jugular veins. So where your jugular veins come down and your subclavian veins come across, where they meet in that T-junction, that's where you're going to find your lymph fluid joining the rest of your circulation. Now remember, your lymph fluids also flows, it comes up via the lymph vessels, but it also goes through the nodes, and the nodes are what cleans things out. Your tonsils, for example, are lymph nodes, and what happens when your tonsils work too well, you end up with a sore throat. Why? Because the tonsils will swell because they're full of all kinds of germs and things that they've cleaned out of your blood. So we're going to have the right jugular, and there's the subclavian, and what do we have here? We have the right lymph duct, and it opens into the subclavian vein. All right? Here you have the left jugular vein, and the main lymphatic duct opens into the subclavian vein. So remember, your subclavian is going to run this way, or rather it's coming back from your arms. Subclavian's coming back from your arms, and jugular, and where they meet, that is where you're going to find those the lymphatic ducts. And that's probably the most important thing you need to do. Also remember, we have groups of lymph nodes, especially here, and you'll be able to feel it. If you take your fingers and just where your pelvis ends and your legs start, there's like a hollow here for everyone. And if you feel in there, you can actually feel your lymph nodes. All right, your tonsils also, but I mean, you can have a look. If you still got your tonsils, you'll be able to see them in the mirror. But your other lymph nodes, you really can't just feel or see. But also for women, for example, when women get breast cancer, the problem is that if you don't catch the breast cancer early, because you've got lymph nodes here inside our armpit over here, it's so close to the breasts, they end up with lymphatic cancer. And it spreads so quickly, because once it gets into your lymph system, it spreads. Right, so ladies, girls, make sure that you check regularly for any kinds of lumps, and go and sort it, have it sorted out. Okay, the lymphatic system, the lymph vessels are located as a network. I mean, you can clearly see, look at this, It is an absolute network. Now, something else you can notice here is that it comes from here and it runs in one direction. So your lymph vessels are certainly not, or your lymphatic system certainly doesn't look like your circulatory system. All right, definitely not. So you must remember the lymph fluid always flows in one direction. It flows from your toes all the way up into the subclavian and jugular veins where the junction is. That's where they enter the rest of circulation. So the lymph vessels assist the circulatory system, okay, and all the cells of the body by removing the wastes, the germs, and excess water from the tissue fluid. Now, have you ever noticed that, you know, when you do a lot of sitting, like when you are studying for exams and you are just sitting at a desk, on your chair, working. And after a while, you get up and your feet almost feel a bit swollen. And if you sit for a long period of time, like 4 or 5 hours on a trot, you're going to find your ankles will start to swell. The reason for that is that lymph fluid only moves up the lymph vessels because of the contractions of muscles. So when people, for example, fly, and they fly overseas and the flights are 6, 8, 10, 15 hours, you don't exactly walk around on an aeroplane. I mean, the longest you walk is when you get up and go to the loo and come back. So it's not a lot of walking. So they encourage you on long flights to actually do exercises. So you put your feet up and you flex your feet and you turn them around left and right, and all kinds of exercises to get the muscles to move so you can get the fluid away from your feet. Okay, lymph vessels carry fluid in one direction only. Now remember, your blood circulatory system carries fluid in 2 directions, arteries and your veins. All right? Here, it only ever moves in one direction, from the bottom of the body up to the heart. Okay, valves prevent the lymph fluid from flowing backwards, so they're going to have valves as well. So if I asked you in an exam, what is the similarity between a vein and a lymph vessel, you'll know that they both contain semilunar valves. All right, muscle contractions will push the fluid upwards. Your blood vessels play a major role at 2 sites. Okay, I mean, your lymph vessels play a major role at 2 sites. One, tissue fluid, and the other is in the villi. Now, the villi you did when you did the digestive system. All right, you've got the villus, which is the little single 1 millimeter high outgrowth that you have in the small intestine to increase the surface area for absorption. All right, now, here's the lymphatic system. This is just to show you what a lymph node looks like. Now remember, afferent always means to arrive, and efferent would mean to exit. So your afferent vessels are going to bring fluid to the lymph node, and your efferent vessels will always take the fluid away. The hilum is the middle part. You've got your sinuses or little cavities, that's the whole capsule. And in there you have little nodules. And in the nodules, that's where the whole filtering process takes place. And your lymphocytes are going to be doing their thing, because lymph and lymphocytes are your real soldiers. All right, lymph at tissue level. The arterial blood is under high pressure. Now we know this, okay? Any blood from the artery is under high pressure. And that causes some of the plasma to move from the capillaries to the tissue fluid, okay? The tissue fluid bathes the cells. Oxygen and glucose diffuses from this into the cells, and your wastes are going to diffuse out. But sometimes you can't get all the waste away. So tissue fluid drains into the capillaries, which leads into the venule, which then eventually becomes veins. But your tissue fluid also moves into the lymph vessels. So it's like an extra way of ensuring that you're not keeping excess liquid around the cells in the tissue fluid. You've got to make sure that that tissue fluid is replaced all the time. Okay? Now, very important, the lymphatic system empties into the subclavian veins. The lymph fluid moves up the body because of muscle contractions. So imagine you've got this lymph vessel like that, and you've got your muscles, and as your muscles contract, so this liquid is pushed up, okay? And they're valves. So when there's no more pressure and the muscle relaxes, the blood doesn't run backwards. The lymph fluid doesn't run backwards because the semilunar valves close. Then the muscle contracts and it pushes it up, and then the muscle relaxes and it comes down and closes the semilunar valve. That's how it basically works. So it's because of muscle contractions. The valves are present in the lymph vessels, preventing any kind of backflow. And those valves, remember, are semilunar valves. Okay? When a person stands or sits for a long period of time, I told you this, the lymph will collect in the feet and the lower legs, and it will cause lots of swelling, and we call that edema. All right, that's edema, and especially if you're flying, you are really going to see it. Sometimes people get really fat ankles. All right, now, lymph in the villi of the digestive system. Now, I don't know if you remember the villi. You've got this little structure that does this. You have your endothelium, but what I want to do is the main part here. This is your lymph vessel. And this little part that sticks up in the villus, this is called the lacteal. Okay, and what happens is your fats, so let's do this. Your fats split up into fatty acids and glycerol. Okay, now they start to move, and they can't. I'm just going to draw the blood system in here. Okay, they're your capillaries. Okay. The fatty acids and the glycerol go along, and they can go through the single layer of cells, but they are still too large to fit here into the capillaries. So because they now can't fit in the capillaries, they are now going to keep on moving until they get to the lacteal. And when they get to the lacteal, they are able to diffuse in. All right, so all the fatty acids and the glycerol then go into the lacteal. And once it's in the lacteal will take it away and carry it away. So just to go back to what this whole process is about here, we have the villi, are small finger-like projections, and they line the small intestine. In the center of each villus is a lacteal. So lacteal is in the villus, and that flows into a lymph vessel. Nutrients and water are absorbed into the tiny capillaries, but our fat molecules are broken down or hydrolyzed into fatty acids and glycerol. All right, so we're going to have one glycerol, and we're going to have 3 fatty acids for each fat. These monomers pass through the columnar epithelium of the villus and immediately join up again to form fat molecules. So now they can't fit into the capillaries. They're too large. So they enter the lacteal. And this fluid here, this fluid inside the lacteal, which is our fatty acids or our fats and the fluid, excess fluid, etc., that fluid is called chyle. So the fluid is called CHYLE. Remember, in the stomach, you had chyme. Chyme was your digestive juices plus the food that's churning in your stomach. Chyle is the fluid in the lacteal. So just remember, the lacteal starts with an L, and it contains chyle. And the chyle drains into the lymph vessels. Okay, so that, and then that goes off into the lymph vessel. Functions of the lymphatic system, people, please make sure that you understand this and that you are going to be asked it. You will get it in an exam question, exam paper. So it's why do we have the lymph system? It's for drainage of excess tissue fluid. Return the plasma proteins back to circulation because they're not being broken down somewhere. Removal of bacteria and toxins. Transport of absorbed fats from the villi, and then the manufacture of lymphocytes. And lymphocytes are our soldiers. So this is the function of the lymphatic system. Let's go through it again. To take away excess tissue fluid, to return plasma proteins to circulation, the removal of bacteria and toxins, because that's what lymphocytes do. And it produces the lymphocytes, and it transports the fats via the villi. And that's the biggest reason why we have the lymph vessels or the lacteals in the villus. Why? Because it has to transport those fats. Otherwise, we're never going to absorb those fats. And the fats cannot fit into the tiny little walls, that little single layer of endothelium cells in the capillaries, which are in the villi. Can't fit in there. So it has to wait to get into somewhere. So it gets into the lacteal and forms a fluid called chyle. All right, let's look at our last question here. It says, study the diagram of the lymphatic system and answer the questions that follow. So here we've got our lymph vessel. First thing we're going to do is we're going to look at our labels. So let's go with orange. Now, if we look at this vessel here, you can see it's not part of the lymphatic system. All right, it's going to be a vein because it's going to be coming into, now remember, this is the right side and that's the left side of a diagram. You're looking at this person lying down in front of you. Right side, left side. So right side here, this is going into the heart. So it's going to be a vein, and it's going to be the subclavian vein. Okay? And then number 2 is going to be our thoracic, lymph duct. It's the lymph duct. Number 3 would be, okay, so this is the right subclavian vein. That would be the left subclavian vein. Okay, number 4, that is a main duct, okay? It's not just any lymph duct, it's a main lymph duct. So, and it's coming past the thorax. This would be, if we were insects, this would be our thorax, okay? Or up to our rib cage anyway, would be our thorax. So, and it's going past there, so it's the thoracic duct. That's the main duct, right? And then 5 would just be a lymph vessel, and 6 is going to be lymph nodes. All right, now let's look at our questions here. Name the components of the lymphatic system. So what would the components be? We're going to have lymph capillaries, those are the little things that are going to stick, that you find in the capillary network and in the tissue fluid which bathes the cells. So your lymph capillaries, and the lymph capillaries are going to join to form lymph vessels. Okay? And your lymph vessels are going to flow through and form lymph ducts, which is a big pipe, it's like a vein, versus a venule versus a vein. And then in the comparison, then you'd have your lymph nodes, because everything flows through the nodes. So if I take an artery and a vein, we've got an artery, splits up into arterioles, splits up into capillary network. Capillary networks join up to form venules. Lots of venules join up to form a vein. Now, the same thing here, except that you've got your lymph capillaries, and we're only going in one direction. So you've got your lymph capillaries will join up to form lymph vessels. The lymph vessels will all join up to form one big lymph duct, which in this case is our thoracic duct, which you can see here. Okay, and everything passes through these little bubbles that we see here in our diagram, and those little bubble things are the lymph nodes. And it's in those lymph nodes that the lymphocytes are going to do their thing, and they're going to be taking out the germs and sorting things out. Now, identify the blood vessel number 3, number 4, and number 6. So let's look at number 3. Is the left subclavian vein. Number 4 is the thoracic duct. And number, what was the last one? 6. And number 6 would be a lymph node. All right. It's pointing to 2, so it would be lymph nodes. You'd have to put plural. All right. Then name 2 factors that assist movement of the lymph fluid. Now, people, the 2 factors are going to be muscle contractions. Okay. Muscle contractions due to skeletal muscle movement. So as we move our skeleton, as you walk, as you lift your foot and turn it around and do the exercises when you're on an aeroplane, all of that is going to cause this fluid to move up. And secondly, there are valves. Valves, you can put semilunar valves. To prevent backflow. Okay, and lastly, you can also say that there's the pressure of the lymph fluid coming in at tissue level. All right, but that's not really a major factor which moves the fluid up. What moves the fluid up is muscle contractions and those valves that stop the lymph fluid from flowing back. All right, and then if we look here, list 4 functions of the lymph in the human body. Now remember, first one is to drain. So it's drainage of excess tissue fluid. Because remember, you're going to find lymph vessels at all our tissue level, So wherever we've got capillary networks and tissue, we are going to have lymph vessels. So drainage of excess tissue fluid. We've then got return, because while it's draining that excess tissue fluid away, it's returning the plasma proteins. Remember, that's the proteins that we're going to find in between the cells, to circulation. That's why it's important for our lymph system to join the rest of our circulation and not just work on its own. It has to join the rest of circulation. Then any wastes and any germs and any bad things that's put into the blood will be filtered out by the kidneys. Okay? And it will be rendered completely harmless by the lymph nodes. All right, now, so talking about bacteria and toxins and bad things and germs, removal of bacteria, germs, and toxins, clearly from tissue level. Absorption, well, it's not really absorption, it's transport. Transport of absorbed fats. Remember our fatty acids and glycerol, which we group into fats at the villi, so that can join the rest of our circulation. And then, of course, we've got our lymph nodes, and the lymph nodes we are going to find produce or manufacture lymphocytes. Okay, and there you go. Now, cardiovascular diseases, people. If we're looking at these diseases, what are we going to expect? First of all, if somebody's healthy, they're eating properly, they're exercising regularly, they're not drinking, or not in excess, they're not smoking, smoking's bad for you, then you're going to live a good life and you're not going to end up with cardiovascular diseases. All right? When people are not good, and they overeat, they overindulge, they smoke too much, they don't do exercise, and they don't eat healthy food, they end up with issues. The body says, I'm sorry, I can't deal with this. So let's look at our cardiovascular diseases. Cardiovascular disorders are a major cause of death in modern societies, like heart attacks and strokes. An angina is caused when the heart muscle receives an inadequate supply of blood, resulting in a very painful cramp in the chest area. So an angina is almost like a muscle cramp of the heart, but it's an indication of a heart attack. So it's what we refer to in common language as a mild heart attack, is an angina. Then we start off with a myocardial infarction. Now, myo means muscle. Cardial means of the heart. So it's basically telling you infarction means that the heart says, I've had it. I'm tired now. You won't look after me. I'm tired. And it's the heart muscle now saying, so far, no further. So myocardial infarction is the proper name for a heart attack. And you have extreme pain in the chest and always the left arm. Okay, now think about it. Why would it be the left arm? Because where do you have the most muscle in your heart? It's on the left side. Why? Because it has to pump the blood out through the aorta. Okay, so you have this extreme pain in the chest and the left arm. A severe heart attack can lead to death. Now let's look at the causes. You've got hypertension. Remember, hyper is high blood pressure, stress, smoking, unhealthy eating habits and poor diet, very overweight or obese, and high levels of cholesterol in the food. And when you're eating takeaways every night, you have high cholesterol. Now, we have Anthro Sclerosis. Now, sclerosis you will know already from grade 10 coming through to grade 11. Sclerosis means to break away or to break up or to mess up. Okay, no longer good. So arthro would be when you're looking at your artery and your arteries are now blocking up. They're not working properly. That's what atherosclerosis means. So within this disease, you're going to have your fats and excess calciums and cholesterol. These are deposited on the artery wall. Now, you've got to understand, you've got this lovely hose pipe, this tube that's all nice and clean. And now you've got a glob of fat that sticks there, and a glob of cholesterol sticks here, and a glob of calcium sticks there. And so all these, or a calcium crystal sticks there, and it starts clogging up more and more and more and more and more and more and more until the lumen is vastly decreased. Okay, so it reduces the diameter and makes the walls thicker, harder, and less elastic, because you've got this gunk collecting on the inside of this lovely little artery. Blood gets caught in the cavities and the blood clots form. Why? Because the blood's not flowing through. So the blood gets stuck over here on a piece of whatever, a piece of fat or a piece of cholesterol, and it sticks there. Blood's not moving. So it's sitting here and it says, well, hold on. There's a problem here, and the platelets start making a clot, and as that blood starts to clot, that's when we have problems. Okay, when a patient is diagnosed with Anthro Sclerosis, a surgeon performs a coronary bypass to remove the blockage. Okay, coronary of the heart bypass, they'll take a piece of vessel and bypass that blockage. In some cases, laser angioplasty is prescribed, where laser beams are used to dissolve the blockage. Okay, angio, heart, angioplasty, part of the heart. So you're using the laser. Sometimes the blockage can be removed by inserting a balloon, and this is actually quite sweet. That it is a balloon, and it's not like a balloon that Jumbo rides in, but it's a little tiny balloon that they actually insert, and then they blow up this little balloon, and it opens the artery up nicely. And that's called a percutaneous transluminal. Now remember, transluminal, a lumen is the opening of the artery. Coronary, to do with the heart. Angioplasty, you're trying to fix it. Okay, so that's what, and we end up just abbreviating it to a PTCA. So when your granny or your grandpa's had a PTCA, now you know what it is. Okay, causes of Anthro Sclerosis are unhealthy eating habits, poor diet, lack of exercise, and stress. People's stress is the killer of today's society, because what do people do? They eat wrong, they don't live right, they're very stressed, they don't have time to just chill and relax, and that causes so many problems. All right. Okay, people, here's Anthro Sclerosis. This is what it looks like. So just look at all these bits of fat and stuff that are stuck on the inside of this little blood vessel. So as the blood's coming in, you're going to find that it's got no smooth way to go. So it's going to start making clots. Okay, let's look at arrhythmia. So arrhythmia results when there are abnormalities in the heart rhythm. So A and then rhythmia. So the rhythm is not right. It is a rhythm. So it's not correct rhythm. Because there was a problem with the sinoatrial node. Now remember, the sinoatrial node was the pacemaker. It's the sinoatrial node that lets the heart know, and it's on the right, lets the heart know that the atria must relax, the atria must contract, the ventricles have to relax, then the ventricles have to contract. And that information comes from the pacemaker. And if you remember that the pacemaker is controlled by the medulla oblongata, and the medulla oblongata will let the pacemaker know, listen, you need to beat faster, or you need to beat slower, or everything is just right. Implanting an artificial pacemaker under the skin can regulate the heartbeat and correct the condition. Arrhythmia is generally caused by genetics, and also by the degeneration of the pacemaker in the region of the wall. And you will have seen in some movies, a guy walks through the scanners at the airport and it goes mad because of his pacemaker. All right, and that's in the old days when the pacemakers were like quite a huge thing. Now they aren't. Okay, strokes. A stroke is the disturbance in the brain function due to either a blockage in a blood vessel supplying the brain, that's about 80% of the time, or a bleeding out of a ruptured blood vessel causing a hemorrhage. Okay, so 80% of the time it's a blockage and 20% of the time it's a hemorrhage. But you've got to remember that there isn't a lot of space in the brain. All right, you've got the brain tissue, you have 3 membranes with a little bit of cerebrospinal fluid to protect and act as a shock absorber, and then you have the skull. So there isn't a lot of a place there. Now, if we end up with a blockage, part of the brain is not going to get oxygen. When cells don't get oxygen and nutrients, they die, which then results in brain death. And that is why, depending on how severe a stroke is, people can lose the use of the entire half of their body, or just maybe have a little bit of a slack face, or a bit of a not be able to hold their hand, close their hand into a fist. So it depends on the damage that is caused, and that damage will, the damage will depend on the amount of blood blockage or blood that's not getting to other parts of the brain. So if, for example, you had a blockage here at the occipital lobe, you could actually impact on being able to see. Not that your eyes aren't working, but that your brain's not interpreting. The same with hearing, the same with speaking, reading, etc. Okay, so 80% of the time would be a blockage, and 20% of the time would just be a ruptured blood vessel bleeding out. An obstacle in the brain's blood supply prevents oxygen and nutrients from getting to the nerve cells. So what happens? The nerve cells become damaged and they die. And when they die, it disturbs the brain function and the central nervous system and the way it works. So blood from the ruptured blood vessel within the cranium compresses the brain tissue, causing paralysis, speech loss, possibly death. Okay, all of that is because of a stroke. And if you know anybody who's ever had a stroke, they very often battle to speak, or they'll end up with half their face sort of droopy because the brain isn't working properly anymore on that side. It is a major cause of disability and death amongst elderly people. Strokes are often associated with high blood pressure and Anthro Sclerosis. Now remember, Anthro Sclerosis, the blood can't pass through very nicely. Okay, and that would be because of a whole lot of cholesterol buildup and fat buildup in the blood vessels, unhealthy eating, and not enough exercise. Okay, but strokes are not fun. They're not nice. And, you know, very often people can go to sleep and they can have a minor stroke and wake up the next morning without having experienced any pain. And imagine you can't close your hand, or you can't speak, or you can't read anymore because that part of your brain was damaged. Okay, anemia results from a lack of, okay, now we're looking at anemia, which is going to affect your oxygen carrying capacity. So it results from a lack of iron. And this is so silly because it's so easy to fix. When this happens, your hemoglobin, okay, cannot be produced. Now remember, hemoglobin is part of your red blood cell, and its job is to carry oxygen. It's like an oxygen taxi is the best way to describe it. It's an oxygen taxi. So if there's a lack of hemoglobin, the cells are not provided with the correct amount of oxygen, and therefore you don't have energy. So a person will feel faint and weak, and the best way to know whether you are anemic is if you're sitting down or lying down and you get up quickly and you get that head rush. It means you're anemic. Also, if you look on the inside of the whites of your eye, if that's very white, then it means you're anemic as well. All right. When the person stands up, and I've just explained that to you, the heart will be stressed, all right, as it has to pump more blood to the blood vessels so that the cells can receive oxygen, and it can also cause palpitations, so you start to get the shakes. So just make sure you have enough vitamins, iron. All right, there's Professor Chris Barnard, and he is a South African whom we're very proud of. He was the man, a doctor, a surgeon, who performed the first heart operation that actually was a success. All right, so we're very proud of him. He's dead now, but here you go. He's a cardiothoracic surgeon, and their teams perform operations, surgically repair and replace diseased heart. Okay, so they'll take a diseased heart out of a person and then take a healthy one from a donor and put it in. During heart surgery, a patient is placed on a lung-heart machine so that the blood remains oxygenated and pumping through the system. The coronary artery disease, heart valve disease, congenital heart defects can all be treated surgically. So we have a coronary bypass, which involves just a piece of vein, and it's put somewhere, and it just bypasses the blockage. All right. Heart transplants are only considered when there is no other option, right? I mean, if you take someone's heart, they can't survive. So there aren't a lot of hearts out there that are sort of ready for everyone to go and pick and choose. It's not a supermarket. So we have to make sure that it is our last option, and also we have to make sure that it is a very, very specific match. Now remember, genetics, we have our own proteins in our body. It must be a perfect match, or else it's not going to work. This is what a heart transplant is. They actually cut their aorta, they cut here from the venae cavae, and because they're going to join that to the other person, to the recipient's tubes, and they take the heart. All right, organ transplants, people, legislation. In South Africa, we may not sell organs. Okay, you may not. it's wrong. If you get caught, that's it. You go to jail for a very, very, very long time. So what happens is our organ transplants are arranged by hospitals and the specialist surgeons, and it's based on very strict rules and regulations. Okay, they're going to check the organ recipient and that the rating is listed. So they're going to first of all check, are we going to do this heart transplant and give this person a heart and they're going to live for a week because they've got cancer of the colon? You follow? They have to make sure that the person they're going to be giving this heart to is going to actually be healthy enough physically with everything else to enjoy that heart for at least a year or 2 or 3 or 10. You follow? So they're not going to give it to someone who is actually dying of lymphoma or lymphatic cancer and just give them a heart so they can live for another week. It doesn't work that way. So first of all, they've got to check that you really need it. Secondly, they have to do tissue typing and make sure that the chances of you rejecting that heart are as little as possible. All right, so your related donors are thoroughly screened first to ensure that they are left with a 100% functioning organ. Now, this is clearly if there's a kidney transplant, okay? But in the case of a heart, they're going to make sure that it's a very close tissue typing, so the chances of rejection are minimal, and they're going to make sure that it's worthwhile doing the operation. All right, so what kind of chances do you have of surviving? If it's less than 50%, they rather give that heart to someone who's got a better chance of surviving. And then if we look at kidneys, well, there we go. They're going to check that it's the one that you left with as the donor is a good kidney, and that the one they're taking out of you is not just nonsense, that it's really a good kidney as well, because they're going to give it to someone else and hope it works. And then ethics and beliefs. You can be asked a question in the exam to discuss whether you are pro or anti-organ donation, whether people should all sign a piece of paper when you get to 18 and you go and do your ID books and et cetera, that you actually put yourself on an organ donor list. So if somebody does need a cornea or lungs or kidneys or a heart, that they can actually give it to somebody. A lot of people are against that, and they say it's not right based on their religious beliefs. But you have to be able to discuss the ethics and the belief systems, your ethics and your belief systems. So registering on a donor list, giving blood donation. Some people are against that. Some people don't believe that they believe it's wrong because blood is your life force. If you bleed out, you're dead. So it's your life force. And they believe it's wrong to give that blood to somebody else. You may not believe that, you may not think that, but you should be able to respect other people's opinions. Organ donation and organ receipt, getting an organ. A lot of people have issues with this, and you must be able to discuss ethics and your belief systems and say, this is why I think it's good, ABC, and this is why I will never ever do it, because it's against my religion, because in my religion we believe ABCD. You can't just say I think it's wrong. You'll get naught. All right, so that's it for today. I hope you've enjoyed the heart. Maybe there's some of you out there who now want to go and pursue being a doctor. I love physiology, and I hope that's been passed on to you. So good luck, enjoy, and study hard. Bye.